Hello, we're looking at problem number 1 found on page 523 of your Geometry Part 2 textbook. This is under lesson 8-5 called the Law of Sines. The Law of Sines is simply being able to compare a side with the angle opposite that side by taking the sine. And so if we see this triangle over here to the left, we see that there is a connection again between these two right here, and then of course you've been given 48. Now it would have a connection with this side right here, which is CB. So in this particular question it said to the nearest tenth, what is the length of BC, which is the one that we are definitely interested in. The way that the law of sine works is you're going to say the sine of the angle is to the side opposite it. So sine of 93 is to 15 equals the sine of 48 over, and then of course BC, representing the side that we don't know. If you cross multiply, this is actually going to end up being BC sine of 93 equals 15 times the sine of 48, and then you would divide both sides by the sine of 93, and that's how they're getting all this, is that they cross multiplied and then divided out so that BC is finally by itself. So the rest is just putting into your calculator. You're going to press, now be careful, please make sure that you check your mode on your calculator and make sure that you're in degree mode. Since we're doing trig functions here, you need to make sure that you're in the degree mode and not radians or some other measurement. Okay, you can do that under your mode button on your calculator. So press 15 sine of 48, get an answer, and then divide that by the sine of 93. And what you're going to find out is you're going to get some answer like this. If we were to round that to the nearest tenth, as they ask, it would be approximately 11.2. Okay? Now, number 1 here says, in that same triangle, what would A be to the nearest tenth? Now, AB is this side right here. So that means that to be able to do this, though, we've got to know this third angle. And it wasn't given to us, but that doesn't mean it can't be found, because if you have 93 as one of your angles and 48 as the other, you would add those two angles together and subtract from 180, because the three angles of a triangle always add up to be 180. And so by doing that, what I found out was that this last angle right here, angle C, ended up being 39 degrees. If you had 93 and 48 together, then subtract that from 180, you would get 39. So the way that we're going to set this up is take one of them that was actually given to you. Like we figured this out, so that was not given. The two connection ones that were given, I'll do it in red so you can see a little bit better here. These are the two connections. So I'm going to say the sine of 93 is to 15, because that was the two that was actually given us in the original problem, equals the sine of now 39 degrees, because C would be across from AB, is to AB. Okay? Again, if we cross multiply to solve this, we're going to get AB times the sine of 93 is equal to 15 times the sine of 39. I'm trying to get AB by itself, so if I divide by the sine of 93, I would get my AB by itself. So AB is going to be 15 times the sine of 39, and divide that by the sine, the sine of 93 there. Okay? And when I do, I end up with something like 9.52, something like that. And if we're going to round that to the nearest tenth, then AB would just be roughly 9.5. All right. Hope this was helpful to you. It's a very useful part of trigonometry called the law of sines, but it's also very helpful to show the correlation or the connection between the sine of an angle and its opposite side.